Okay, not a good way to start our last section. Oh my gosh. Okay, so welcome back. We're here, and take a breath. We are now jumping into our very last section. If it helps you to know what we're covering, you basically have 4 sections and the final. So no more tests except the final. And so all the material that we're covering in these last few weeks will be on the final. So there'll be, 5 to 7 questions on the final covering the stuff that we're doing, maybe more. I might weigh it a little bit heavier. The good news is, again, we only have 4 sections left, and then we're going to do the, get my stuff out, do what's called the antiderivative. Okay, so anti means opposite. So when we found the derivative, we were, finding the slope of a line. Now we're finding the antiderivative. So you're going to feel like, okay, this isn't overwhelming. It's not something that is super difficult because we're just going in the opposite direction. The problem is when you get to the final, remembering, okay, derivative, I do one thing, antiderivative, I do the other. So that's the hardest part for this section, but being able to undo something kind of helps you understand what you're doing. So let me share my screen here, and I'm going to give you a visual of what an antiderivative is. See, I wasn't the latest one, so that's good. Okay, so when we're looking at, let me open a new page here. When we're looking at antiderivatives, so there's several different terms. Okay, so just like the derivative was slope, derivative was instantaneous rate of change, derivative was marginal. Remember the term marginal? Derivative was differentiate or differentiation, implicit differentiation. So all of those terms mean the same thing. It means finding the derivative, finding the slope of the line at a very specific point. Antiderivative has the same thing. Antiderivative, you can use integration, and you can use integral. All of those terms also mean the same thing. So what we're doing, so instead of now starting with a function, now we're going to start with the derivative and take it back to the function. But visually, what we're looking at, so if I draw this picture, and I have this function, so we're going to call this f of x, okay? What we're doing is if I put a barrier right here and say, okay, I want to stop, let's just say we're going to stop at this value c. We don't know what it is, we're just going to stop at that. And I want to know how much area I have underneath. So I want to know all of this area. That's what we're finding with antiderivative. We're finding the area under the curve. So in this case, it's between the curve, f of x, and the x-axis. So we're looking for all of that area under the curve. If you guys have taken or in the future, if you're going to take micro or macroeconomics, which most of you are going to have to take, you'll hear terms like Lorentz curve, Gini index. We're going to cover that on Thursday. And then you'll also hear terms like producer surplus and consumer surplus. And so what we're doing is we're looking for the area between 2 curves. And that's what anti-differentiation is. It's being able to find the area under the curve. The notation of it looks like this. So This is the integral sign. And if you look at it, it's kind of like a stretched S. And that stretched S, you want to think of as the term sum. Okay, so we're adding something together. So to find the area under the curve, if I broke this up into sections, I would have the height would be my f of x, right? Because it's coming up to this point to my function. The width would be the change in x. Okay, so what I'm doing is I'm finding the area of each section, saying height times width, and then I'm adding that all up. So I'm getting the sum of the height times the width, and that gives me the area under the curve, which is the antiderivative. Okay, now if I create more and more and more little rectangles, the smaller they get, the more precise my function or my area is going to be. Because once I start really breaking them up into real small chunks, then I'm going to get really close to what the area under the curve is. So this is the notation that you're going to be used to seeing. This is called the integral sign. This is your whatever your function is, and this is in terms of x. So you can think of it as the width of each piece that you're adding up. Okay, so we're adding up all of these little rectangles. So instead of actually doing that and breaking it up, it's called, I think it's called the Riemann sums. I'll have to look that up again. It's been a while. And you literally take the area of each piece and add them all up. Well, instead of having to do that, we use the technique of integration. Okay, and integration is the antiderivative. And so literally what we're doing is we're finding the area underneath the function. So we're going to start with something called indefinite integrals. And when let me get to, I was supposed to have all this out already. Sorry, you guys. I failed you today. Okay, so if I start with this function, okay, let me get this out of the way here. If I start with this function, I have x squared, right? What's the derivative? And someone answer me. What's the derivative of x squared?
2x.
2x, right? So super easy. We know how to use the power rule. What if I had x squared plus 1? What would the derivative be?
2x.
2x again. Okay, so it's the exact same derivative, but two completely different functions. If I had x squared minus 4, what would that be? The derivative.
Same.
Still
Same
2x.
thing, right? So what this is called a family of functions. And this family has all this exact same derivative. Okay, so we're going to do something in this antiderivative technique so that I can say, okay, we don't know which of these three it is, which of these three functions it is, but we know in general the antiderivative the derivative is 2x on all of these. Okay, so keep that in mind as we're going through these problems. All right, so we have an integral sign, we have the function, and we have in terms of x. So this dx can change. It can be in terms of time, it can be in terms of u, it can be in terms of whatever variables we're using. So this part right here can change depending on what our function, what variables our function has. Okay? All right, so here we go. So our first section, I thought I had, I'm sorry. I thought I had, oh, I know where it is. Hang on, let me find it. So, and I'll post this form that I'm getting right now is in your Canvas under PDFs for the class. Let's see if I can find it real quick here. So this is kind of the overall general picture of what antiderivatives are. And so I wanted to show it to you so that you can see all the different, I gotta find it. Is this it? I think this is it. And we're gonna do two sections in a, this is really hard to do this and talk at the same time. 2 sections in chapter 12 and 2 sections in chapter 13. So I don't want you to think that, oh my gosh, we have, all this stuff that we have to do. We actually are only doing 2 sections in each chapter. So we do have 2 more chapters, but 2 sections per chapter. Oh, come on. Thought it would be close. Okay, so this is these are all the basic rules of integration. So there's all your terminology: anti-differentiation, antiderivative, integration, integrals, area under the curve. All of that means taking the antiderivative. All right, so again, it's the reverse operation of taking a derivative. So remember when we were taking derivatives, if I asked you to find, and we just did this, if I asked you to find the derivative of this, right, we ended up with 2x. Well, when you did that, what was the process? What did you do first? How did you go from x squared to 2x? What was the process? Do you remember?
Multiply the power by the coefficient.
Okay, very good. I love the terminology, Nathaniel. Excellent job. So you multiplied first, right? So we multiplied, and then what did we do?
Subtract.
Yeah, then we subtracted 1, right? We took off 1 here. And that was the order that we did it in. We multiplied first, and then we subtracted. Well, when you're doing anti-differentiation, I can't spell, you're going to go in the opposite direction, okay? It's the inverse, right? It's complete opposite. So when you do, so this is when you're finding the derivative, this is the antiderivative. Can't spell. So the first step you're going to do, what's the opposite of subtracting? Adding, good. And then what's the opposite of multiplying?
Division.
Division. Okay, so this is the order that we're going to go in, because we're going in the anti or the opposite direction. We're going to add first, and then we're going to divide. So when you get on the final, you're going to have both finding the derivative and finding the antiderivative. You have to keep them separate. It's going to be super important that you keep those separate and you don't get yourself mixed up. All right, that's probably the biggest challenge, is making sure you don't get yourself mixed up on which is which. All right, so here we go. So with these rules, get this out of the way. With these rules, here is number 1 is, so here's our our integral sign. This is the integrand, that's the constant, and then you have the general antiderivative is whatever the antiderivative is, that's that plus c, that's that family of functions. Okay, so number 1 says when you get and you're finding the antiderivative, I'm looking right here. Oops. Oh, dang it. Can tell this day is not going to go well. Okay. So I'm looking right here. If I have a function and I'm finding the antiderivative, I'm going to add 1 first. So opposite of subtracting 1, I'm going to add 1. And then I'm going to divide by the new exponent. Okay. Now, remember what you're doing. So like on this example right here, you are given a derivative. You're changing it back to the original function. Okay, you're given a derivative and you're changing it back to the original function. That's really key to keep in mind while you're doing this. All right, so the process is It was x squared. I'm adding 1, and then I'm dividing, so I can do it this way. I'm adding 1, and then I'm dividing by my new exponent. Okay, it's dividing by the new exponent. So that's where they end up with x cubed over 3. And then that plus c is because we have indefinite integrals. They're not definite. They're not a very specific one. And we're going to change that really quick. We're going to go through and be able to find the antiderivative and then always add plus c. And then we're going to get to the particular antiderivative, a very specific one. So remember that family of functions. We're going to be able to choose which specific one we're going to use. Okay, so another way, remember, another way to write this is 1/3 x cubed. It's the exact same thing because your 1 is sitting right here. And to me, this looks more friendly than this. Okay, so this is completely okay. You can write it either way in my math lab, but as you're working, this is probably going to be the easiest one to use. All right, now this is the beauty of this. Because we're going in the opposite direction, you already know how to take it back to a derivative, right? Because remember, this is a derivative. This is the original function. So if I wanted to know, did I do this right? I would go, okay, I'm going to find the derivative of this. So the derivative is I drop the 3 to the front and multiply. So 3 times 1/3 is 1. And then I'm going to subtract 1 and I get right back to x squared. So you should always be able to double check, make sure that the antiderivative taking back to the derivative will give you what you started with. Okay, because this is when you're finding antiderivative, you're given the derivative, you're taking it back to the original function. And then you always add your plus c, because the plus c is what gives you that family of functions. We don't know which family of functions this is at this point. We will real quick, we will. Okay, so that's the first technique, and you're going to practice this a lot today. That's the first technique. So it's just in opposite direction. You're going to add 1 to the exponent, and then you're going to divide by the new exponent. Add 1 to the exponent, divide by the new exponent. So again, if you're given the antiderivative of x to the -7, I'm looking right here, then you're going to add 1 right here, which now makes it -6, and then divide by the new exponent. So x to the -6, why is that showing up? X to the -6 over -6 plus c. Okay, so let me give you, let's take a look at some examples and just kind of walk through it. And I have this up here too. So this is the integral power rule, right? You find the antiderivative of x to the n, you add 1, and then you divide by the new exponent, and then plus c, and that is your indefinite integral. All right, and then I'll show you the other ones in a minute. All right, so here we go. So remember when you were just starting out, and a lot of you really struggled with this one, so let's try this. So we're going to go back and forth between finding derivative and finding antiderivative. So remember, d dx is instructions. It's saying find the derivative. So if I had the function 15x, and I want you to find it in terms of x. Okay, what would be the derivative of 15x? What would that be?
15.
Okay, would just be 15, right? So again, using the derivative technique, drop the 1 to the front and multiply, and then I'm subtracting 1, which makes this x to the 0, which makes it 1. So it's 15 times 1, which is just 15. Okay, the other way to look at that is if we were looking at a linear function, and I said find the derivative, or I'm sorry, find the slope. The slope is sitting right there. So my derivative would be 3. So when I look over here at number 1, Now I'm given the derivative, and I want you to find the antiderivative. So whenever you're given a constant, all you have to do is add an x to it. Okay, now the technique of this is what this says is 10 times x to the 0, right? X to the 0 is just 1. So if I'm using that technique of adding 1 and then dividing by my new exponent, look what I get. I get 10x to the first power. So then I'm going to add my plus c. Okay, so the easy way to remember this is if you have a constant, that constant is the slope to 10x. All right, and that's the one that usually catches people. So you have to just remember, oh, that's right, we just have to add an x to it. Okay. All right. So I'm going to do a few, and then I'm going to have you guys put your answers in the chat. Okay. So here we go. I'm going to add one, and I still do this when I'm going through homework and making sure that the homework I give you is the ones that we've covered in class. I will still do this. This is how I learned it. It's what I stick with. So I add one, and then I divide by the new exponent. Okay, -6 plus 1. So again, you have to remember your sign number rules. -6 plus 1 is -5. So my function, the original function, is -4/5 x to the -5 plus c. Okay, now to check it, I'm going to find the derivative of this. So I drop my -5 to the front and multiply. So I end up with -5 over 1, -5 over 1 times -4 over 5. My 5's cancel, so I end up with +4. And then when I subtract 1, I end up with -6. So I know I did it right. And that's just a check. It's just a quick check to make sure that what you're doing is correct. Okay, so sometimes you're going to deal with negatives. Sometimes you're going to deal with fractions, right? So you have to be real comfortable with fractions. So, and again, this is why I always write it out on my, or whatever I'm working with. So I'm going to add 1. So again, with fractions, they have to be a common denominator. And then I'm going to divide by my new exponent. So -5 plus 3 is -2/3. Okay, now this is where people get a little bit confused. I went over this in my, let me make sure I'm recording this. Yeah, okay. I went over this in my face-to-face class, and I had a couple students stay after because they said I went through this way too fast, the fractions. So going back to just your, probably in fourth, maybe 5th grade, remember when you were dividing by fractions? What would you do with that second fraction? What do you
Don't you
remember?
flip it 3 on top?
Yeah, you flip it over and then multiply, right? And then you can either multiply straight across and then reduce, or what I do is I cross cancel. Any top with any bottom, if I can reduce it, I do it ahead of time. So then 3 goes into itself once, 3 goes into itself once, and then 2 times 1 is 2, 1 times 1 is 1, so it's just 2. Okay, so anytime you're dividing by a fraction, you're going to flip that fraction over and then multiply. Okay, so flip it over and then multiply. Well, when I flip this over, now I have a 2 on the bottom and a 2 on the top. So I end up with -3x raised to the -2/3, and then again plus c, because again, I don't know which specific one it is. It's an indefinite integral. Okay, so take a look at that. Make sure you're seeing what I'm doing and how I'm doing it. And if you don't, let me know. Now, obviously, you can use your calculator. right? If you're using the TI-30 like I have, and it doesn't change it to a fraction, or it gives you a decimal answer, you can change it back to a fraction just by using your shift table. And you probably can't see it, but right above the table button on this side right here, it's got F and then an arrow to D and then an arrow back to F. So that shift table will take it back and forth between fraction and decimal. So you can use your calculator for it, but to me, it's faster. Just flip it over and multiply. Flip it over and multiply. That's all I'm doing. Okay. Any questions on that one? I was given, I don't know if you can see this. I was given a Stanley Cup for Christmas. My office mate's wife etches them and makes, she sells them. Anyway, every time I pick it up, all I can think of is that SNL skit, my big dumb cup. Anyway, all right. I can tell I've had too much coffee this morning. Okay, so square root of x. Cannot find an antiderivative of a square root, can't find the derivative of a square root. So the first thing you've got to do is change that to x to the 1/2. So remember, the exponent on the base is your numerator, the index is your denominator. Okay, so now I can do my anti-differentiation. So I'm going to add 1 and then divide by my new exponent. So I'm going to flip this over and multiply. So the 3's go away. So I end up with 2x to the 3/2 plus c. So again, anytime you're dividing by a fraction, you got to flip that fraction over and multiply and simplify it. Okay. All right. I want you to try number 5. And before I show you the answer, go ahead and put your answer in the chat. So there's, how many of you are there? There's 13 of you. So I should have 13 answers. Everybody should participate. While you're doing that and I'm waiting for your answer, I'm going to go ahead and take roll. So we have 1, 2, 3, including today, we have 3 Tuesdays and 3 Thursdays left. So just 6 classes left and then our final on Tuesday the 7th. So remember, we're going to do our final on Tuesday the 7th. It starts at 11 and then it goes to about 1:45. But if you're done sooner than that, you just turn in your test and then go do something fun. All right, still waiting. And ask me questions if you're not sure. Okay, so Javier, go back and look at what you would do with the 1. So the 1 is like the 10. So it's a constant. So you have to do something with that one. And Brian, yours looks good. So for those of you who haven't answered, why haven't you answered? Are you not sure where to start? Are you not sure what to do? Talk to me.
I got the same as Javier, so I know I messed up.
Okay, okay. So so look at number 1 again. You see how it's a constant? Good, Dylan. You see how it's a constant? So remember, with a constant, that's the slope. You're given the slope, and so the actual function is 10x. So it's the same thing with the 1. The 1 is your slope. The 1 is your slope. Let me get my pencil here. And so you are adding an x to it. So anytime you have a number all by itself, you have to add that x to it because that is the original function. So this is the slope on the original function. Okay, so here we go. So we're going to add the x to the 1. So if it's a constant, you add an x to it. And then 2x, we're going to add 1, divide by my new exponent. On this one, we're going to add 1, divide by my new exponent. So I do this, I write it out first, and then I write out my simplified answer. Okay, so I have 1 times x is x. 2 over 2 cancels, so I end up with x squared. And then this one, I end up with 4/3 x to the 3rd power, and then plus c. Don't forget your plus c. So while you're doing 12.1, how you know when the plus c is going to be involved is when your integral sign has nothing here or here. Because on Thursday, all of a sudden, there's going to be numbers that show up. Okay, so when there's nothing there on your integral sign, it's just asking for, just in general, what's the family of functions that gives you this as your derivative. Okay, so again, with antiderivative, you're given the derivative, you have to take it back to the original function. So if I do that, if I take it back to the original function, and now I look at this and go, okay, what's the derivative? Derivative of x is 1. Derivative of x squared is 2x. And derivative of 4/3 x cubed, drop that to the front. The 3's cancel, I end up with a 4, and then minus 1, I end up with x squared. So I know I'm on the right track. I know that this is the function that gives me that as the derivative. So I should be able to go back to what it was. Okay. All right. And then any questions on that one? I only had half a dozen people answer, which concerns me. Make sure that you are practicing, because just listening isn't going to be enough for this. You have to actually walk through it. Okay. All right. Last one. So even if there's decimals, doesn't matter. The process is the same. We're going to add 1, divide by the new exponent. Here, I'm going to add 1, divide by the new exponent. This is a constant, so I'm going to add an x. Okay, now I'm going to simplify it. 0.4 divided by 4 is 0.1 x to the 4th. 0.3 divided by 3 is 0.1 x to the 3rd, plus 1.5 x plus c. And there is my original function. Okay, to test it, to make sure, check it to make sure I'm doing it right. 4 times 0.1 is 0.4, x to the 3rd. 3 times 0.1 is 0.3, x to the 2nd, and then 1.5x the derivative is 1.5. So I can take it right back to my original one just by taking the derivative of it. Okay. All right, so we're good with that. That's your integration or integral power rule. It's just the opposite of the derivative power rule. All right, so now we have some special functions. So let me take it back to, oh, it's here, sorry. Take it back to our rules. Okay, so we just did this one. Now we're going to take a look at e to the x. Well, e to the x is our special one, but it's actually quite easy because remember the derivative of e to the x is e to the x, right? So that means the antiderivative of e to the x is e to the x. So it's really no different. It's just the same because we're just going back and forth. The challenge is remembering, well, what was it, right? Was it e to the x was the original, or was e to the x derivative? Doesn't really matter because it's the exact same thing. Okay, that's one of the special ones. Then the next one is, remember you had e raised to a function. So when we were finding the derivative of that, if I asked you to find the derivative of, say, e to the 4x, all right? The way we did this was like that chain rule, right? E to the x is e to the x times the derivative of the function. So e to the x is e to the x times the derivative of the function. Okay, so that's how we found the derivative. Well, because we're doing antiderivative, we're going in the opposite direction. So instead of multiplying by the derivative of the function, now we're going to divide by the derivative of the function. So that's what this is showing. E to the 4x, finding the antiderivative. We're repeating it, e to the 4x times or divided by the derivative of 4x. Okay, so that's why it's divided by 4. So what I would do if I was doing this one, this is how I write it. I say e, I repeat it, and then divided by 4. Because whatever this is, whatever the derivative of this is, I divide by that number. And that's how they get the 1/4 e to the 4x plus c. Okay, so you can write it either way. But if you're going to write it this way, just remember you're dividing by the derivative of whatever the function is. Okay, same thing here on the next one. Okay, on the next one, e raised to the negative 5x. It's going to be repeat e raised to the negative 5x divided by negative 5. Okay, so e to the negative 5x divided by negative 5. So I get negative 1/5 e to the negative 5x plus c. And that's where this comes in. Okay, so that's your second specialty one. The third one is going back to ln. So remember when I found the derivative, if I was finding the derivative of ln of x, that equaled 1/x. So again, we're just going in the opposite direction. So the antiderivative of 1/x is ln of absolute value of x. Now, the reason why they do these absolute value signs is because a natural log or any log cannot be negative. And so absolute value says, okay, we're going to take that value, but we're only taking the positive version of it. All right, so you could have ln of negative, if x was -4, you could have ln of -4, but those absolute value signs say, nope, it's got to be positive, right? So absolute value means how many steps away from 0. So that's always going to be positive. Okay, so that's why these are going to be important. So when you're doing this in my math lab, at the bottom, there's going to be an absolute value icon. So they're just 2 vertical lines. So make sure you use that when you enter your answer. Okay, now where this gets complicated, I mean, it's not super complicated, but where it can get a little bit it frustrating is, what if you had this? The antiderivative of x to the negative 1. Well, x to the negative 1 is exactly the same thing as 1 over x. You have to remember that. That's going to be really important for you to remember. Okay, so even if you have x to the negative 1, that's still going to be ln absolute value of x plus c. Okay, so maybe in your notes, put 1 over x is the same as x to the negative 1. And then the antiderivative is ln of x. Okay, so going back to our practice, now we have the antiderivative of 15 e to the x. So the constant just goes right along with it. Okay, that's what this rule is saying. This number 5, k is a constant. You just multiply. You can pull it out and then multiply by the antiderivative. Or the way I do it is I just keep it. It just comes along for the ride. So this is 15 e to the x plus c. And that's my original function. Okay. All right. So now we have a radical and we have e raised to a function. Okay, so the first thing I'm going to do is always change that radical to a fractional exponent. Okay, so again, the exponent is my numerator. If there's no index, it's always 2 because it's the square root. And that's your denominator. Okay, so now I can do my power rule. So I'm going to add 1, dividing by my new exponent. Here, I'm going to add 1 and divide by 2. And here, I'm going to repeat divided by the derivative of 3x, which is 3. Okay, so I always do this up here, and then I rewrite it so that I can clean it up. So this, I forgot to add an x to that one. Because it's a constant, I'm going to add an x to it. So I have 2x plus, I'm flipping this over, so 2/3 x to the 3/2 plus x, excuse me, plus x squared plus 1/3 e to the 3x and then plus c. Okay, so take a look. There's more parts to that one, so take a look at that. Make sure it makes sense to you. Okay, no questions? Does it feel like it's okay? Like, okay, I just need practice, but it's not so overwhelming as like the last chapter. Which, by the way, the last chapter, that test you guys took, I was actually very impressed because it is not an easy test at all. And I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of the 15 pass it. That's a fantastic pass rate. So I was very pleased. And even the ones that weren't in the C or above, it wasn't terrible. It could have been so much worse because that chapter is no joke. So thank you for all your hard work. I really appreciate it. I know we're getting to the end and I know you guys are tired. So let's just keep pushing forward until the very, very end. Don't give up yet. Okay, number 9. So now we have u's. So you notice the du. It's no longer dx. It just means in terms of u. That's all that means. So it doesn't change anything, doesn't change technique or anything. It's just a different variable. Okay, so here we go. We're going to add 1, divide by my new exponent, add 1, divide by my new exponent, and then add 1, divide by my new exponent. Okay, so now I'm going to clean it up. So I have flipped this over, 2/9 u to the 9/2 plus, I'm going to flip this. I'll do it over here. I'm going to flip this 7 halves over to 2 sevenths times 2. So now do you see how I have the 2's are both on top? And that's why I actually flip it over and look at it, because sometimes I can get away with, cross canceling. I can't get away with cross canceling on this one. So it's 4 sevenths u to the 7 halves. And then I divided by 2. So that means that 2 is on the bottom. So it's negative 1/2 u squared and then plus c. Now that I look at my writing, I wish my writing kindergarten and first grade teacher would have been rougher on me as far as making sure my numbers are clear. Okay, so number 10, no questions on number 9? You guys good? Okay, number 10, you see this? This 2 over x. So 2 over x is exactly the same as 2 times 1 over x. Okay, so you got to be real careful with these because they can sneak up on you and you can miss it. All right, so the square root of 5 is just a number. Square root of 5 is just like having a 2 sitting in front. It doesn't affect the x. Okay, so the x is not underneath the radical. It's outside the radical. So the square root of 5 is just a number. So I'm going to walk through the process. And so I get square root of 5 over 2 x to the 2nd power plus 2, and the antiderivative of 1 over x is ln absolute value of x, and then plus c. So these can catch you because you're going to look at that and go, oh, I could just, add 1 and then divide. Well, you're going to see what happens when I do that. Okay. All right, so let me show you the red flag. Okay, so I'm going along. Okay, I'm just adding 1, dividing by my new exponent. I'm adding 1, dividing by my new exponent, which means I'm dividing by 0. Do you see how I cannot divide by 0? So that's why your x to the negative 1 is super important, that you know that x to the negative 1 is exactly the same thing as 1 over x. Okay, so we can't do this. That means we have to use it's got to be one of the specialty ones. So here I have negative 1 over 2, x to the negative 2, plus ln absolute value of x plus c. Right, and this catches people. I watched it yesterday in class as I was walking around while they were practicing this. I had probably, out of the 24 students, I probably had 3 of them that added 1 and went, oh, wait, I'm dividing by 0. That doesn't work. And I said, yes, it's a red flag. You cannot divide by 0. So don't just keep going thinking you did it right. That's got to be where you stop. That's got to be your red flag of, oh, wait, stop. I can't do this. It's got to be something else. Okay. All right. So I'm going to leave the last 3 just to save some time. Maybe on Thursday, we'll go back and just double check. So go ahead, in your spare time, go ahead and try these last 3 and see what kind of answers you get. And then on Thursday, I'll go over them and make sure. Okay. All right. So now we're going to go, those again were called indefinite integrals. Now we're going to do particular antiderivatives. So now we get to figure out, okay, which function exactly am I looking at? All right, so these are more written out instead of, and then we're going to do a couple word problems just because you're going to see it on 12.1. So remember what an antiderivative is. An antiderivative is you are looking for, 1, the area under the curve, which doesn't apply just yet. We don't have a visual just yet. We will on Thursday. But we're also changing the derivative back to the cost function. So this is marginal cost, right? Derivative of the cost. We're changing it back to the cost function. So sometimes that happens where we can see how our costs are changing. We want to know what our actual costs are. But in this case, we are looking for the cost when we have 0 products. Our cost is $800. That's what this means. So now we're looking for a very particular antiderivative, very particular cost function. Okay, so what we're going to do is we're going to change this. So we're going to find the antiderivative of 0.2x plus 500 in terms of x. Okay, so we're just going to walk through our process. We're going to add 1, divide by our new exponent, and then because it's a constant, we're going to add an x to it. And then I'm going to clean this up. So my cost function is 0.1 x squared plus 500 x plus c. Okay, so now our job is to find out what c is. That's our job. So now we need to know what both the 0 and 800 represent. The 0 represents the x. The 800 represents the actual cost. Okay, so we're just going to replace. So we have c of x is 800. Our x is 0. And we are looking for c. C is now our variable, what we're looking for. Well, this makes it easy. The 0 makes that go away. 500 times 0 is 0. So our c equals 800. Okay, so what you're going to do is you're going to take this c and replace it with 800. So our actual cost function is 0.1 x squared plus 500x plus 800. So now we have our particular antiderivative. Okay, so now we know exactly which cost function we're looking at. Not just some random indefinite one. So any questions on that? Okay, so same thing here. They're giving us the derivative. They're asking us to find the revenue. So they're giving us marginal revenue. We're looking for the actual revenue function. All right, so this right here kind of tells you what you're looking for. We had to find the cost, we have to find the revenue. So we're going to find the antiderivative, and I'm going to rewrite this because I can't have that exponent on the bottom. So when you move it to the top, remember it changes the sign. Okay, because you can't find the derivative or the antiderivative of 100 over x squared. But I can find the antiderivative of 100x to the negative 2. Okay, so I'm going to add 1, divide by my new exponent. So I get my revenue function equals negative 100 x to the negative 1 plus c. Okay, so that part is nothing new. The new part is now we have to find what c is. So we're going to take out our x. This is our x. This is our revenue when x is 1. So our revenue is 400. Our x is 1. We are looking for c. So we have 400 equals negative 100. And then 1 raised to anything is 1. So we're going to add 100 to both sides. So my c is 500. So my particular revenue function, so you have to make sure that you rewrite this. Because if you don't, if you just solve for c and don't plug it back in, then it will be wrong on my math lab. You have to have the actual function, the particular antiderivative. Okay. I'm gonna jump down. Let's see, I want to get these in here for sure. Yeah, 15 minutes. Okay, let's do this one because it's got e raised to the 2t. So I'm going to find the antiderivative of 8e raised to the 2t minus 12 in terms of t. So e is a special function, right? So I'm going to go 8 e to the 2t divided by 2 minus 12x. Okay, so 8 divided by 2 is 4. E to the 2t minus 12x plus c. So this is what our y equals. And look what we're looking for. We're looking for y. And now I'm going to find my c. So my y is 50. My t is 0. This should be a, sorry, this should be a, not an x, a t. So minus 12 times 0 plus c. Now this is where you have to be careful. This e raised to the 0 power equals 1. It doesn't go to 0. It equals 1. Anything raised to the 0 power is always 1. Okay? So we have 50 equals 4 times 1 minus 0 plus c. So we have, this is 4 plus c here now. So we're going to subtract 4 from both sides. So I get 46 equals c. So my y function is 4e to the 2t minus 12t plus 46. And that is my particular function. Okay. So any questions on those type? Because I want to definitely get to these 2-word problems because you will see these on your My Math Lab. So I want to give you an example of them. Okay. All right. So here we go. So this is an application. This is something that you will see on My Math Lab. So the marginal average cost of producing X sports watches is given by marginal average cost equals negative 500 over X squared. So what you have to remember, to find average, you take the cost function, the total, and divide it by X. You have to remember this, right? We did this early on. To find average of anything, you take the total and you divide it by the number of numbers. All right. What this is the average, the derivative of the average. That's what that is. It's how the average is changing. Okay. So we want to find the average cost function. So they're giving you the marginal average. We're taking it back to the average. So A, our first step, is we're going to take, and I'm going to rewrite it because I can't find the antiderivative when that x squared is on the bottom. So I'm going to take the antiderivative and get rid of this derivative, right? We're taking it back to the average cost. So you walk through the process again. We're going to add 1, divide by our new exponent. So our average cost is 500 x to the negative 1 plus c. That's our average cost. Now we have to plug this value in, and notice it is average, right? C bar means average. Okay, so our average cost is 20. Our x is 125. We're looking for c. So remember, 500 times 125 to the negative 1 is the same as 500 divided by 125. So that 125 just gets pushed down. So 500 divided by 125 is 4. So I have 20 equals 4 plus C. Subtract 4 from both sides, and I get C equals 16. Okay, so A says find the average cost function. So the average cost function is 500 x to the negative 1 plus 16. There's our average cost function. Okay, so it's nothing new. It's what we just did, finding the particular antiderivative. Okay, now it's asking, B is saying, what's the cost function? Okay, what's the cost function? Well, when we come back up here, this is important because we're looking for this, right? So when you look at this, you're given the average cost. You know you divided the cost by X. How would you get the cost by itself? So if I set it up, watch this. If I set it up, this is my average cost. And I know I got that by dividing the cost by X, and I am looking for this. What do you think I'm going to do? Any guesses? How would I get rid of a divided by X?
Factoring.
No, not
Negative one.
factoring.
Power
Say-
negative 1.
So what's the opposite of dividing by X?
Multiply.
Yeah, multiply by X. So I'm just going to multiply both sides by X. What that does is it cancels that. And now what's left is my cost function. Okay, so you just did the exact opposite. To get average, you took the cost and divided by X. To get the cost, you took the average and multiplied by X. So you just did the inverse operation. So this is where knowing what algebra, what the rules of algebra are and how to, kind of manipulate and move things around really does help. Okay, so your cost function is 16x, I'm just distributing, and then 500, I'll do it over here, 500 x to the negative 1 times x to the first, that cancels these two x's, right? Because we add our exponents. So it becomes just 500, so plus 500. That is our cost function. So we're just working in backwards, right? We're doing inverse operations for every single one of these. And then C says, what are the fixed costs? Well, the fixed costs are sitting right here. The fixed cost is 500. So it costs you $500 just to open your doors. Okay. So any questions or thoughts on that one? All right, last one. So example 6 says the rate of change of the monthly sales of a newly released game is given by the derivative, right? The marginal sales, derivative of sales is 500t to the 1/4. And then when x is 0, y is 0, where t is the number of months, so this is really important. Pick up what your variables represent. T is the number of months. S of t is the number of games sold each month. Okay, now this does not mean, this S of t does not mean S times t. This is just a notation. This is that functional notation. This is our sales function. Okay, so determine our sales function. So they gave us the derivative of the sales. So what we're going to do is change that derivative back to the sales function. So we're working backwards. Okay, so anytime you're given the derivative, you're taking it with anti-differentiation, you're taking it back to the original function. Okay, so we're going to add one, divide by my new exponent. So I end up with 4/5 times 500 over 1 t to the 5/4. So I can cross cancel here. Okay, so 5 goes into itself once. 5 goes into 500 100 times. So I'm just dividing. Any top with any bottom I can divide. And then I multiply straight across. So my sales is 400 t to the 5/4 plus c. Okay, well, this one's easy. When x or t is 0, my function is 0. So if I plug 0 in here and 0 in here, my cost is 0. So my sales function is 400 t to the 5/4. And no plus c because the c is 0. So it just drops off. Okay, so this is where knowing what your variables means. So B says, when will the monthly sales reach 20,000 games? Where T is the number of months, S of T is the number of games. So this is my S of T. So I'm going to go 20,000 equals 400 T to the 5/4. I know I'm running out of time. Okay, so I'm going to divide off my 400 first. Oops. So 20,000 divided by 400 is 50. Equals T to the 5/4. Okay, now this is the trick, right? This is another little algebra skill. You want T to be first to the first power, right? We're trying to get this 5/4 gone. So what you're going to do is you're going to raise this exponent, raise this to 4/5, because 5/4 times 4/5 is 20 over 20, which is 1. So whatever I do to one side, I've got to do to the other. So 50 raised to the 4/5 is 22.87 months, because this is in months, number of months. Okay, so almost 2 years. So after almost 2 years, not quite 2 years, you're going to have sales that reach 20,000 games. So it's a prediction, right? It doesn't mean that every time it's gonna be exactly 20,000, but it's a prediction. You get a good idea of how long it will take based on that amount of sales. Okay. All right. Any questions? It takes practice. It definitely takes practice. So don't wait till the last minute. Get right in on 12.1 and get started on it. And then Thursday, we're going to do 12.5. And then we'll do chapter 13 next week, and then the final. Well, then the review and then the final. So, okay, guys, have a good day. I will see you on Thursday, and I won't be late, I promise.
Bye, Miss Taker.
All right, thank you.